Okay, let's do math. Rational exponents. First of all, understand what's being said there. Rational basically means fractions, and exponents, you know, those tiny little things written above your x or whatever else. So we're talking about exponents that are fractions. That's what the lesson is about. Now, radicals, which again, that's just another word for square roots, or roots in general, radicals can be written with fraction exponents, rational exponents. And the way that you go back and forth between the two is shown right here, where n is the index, m is the exponent. The way we transfer that over here is the exponent is on top, the index is on bottom. And it goes both ways. So we can convert from one form to the other in order to simplify expressions, whatever's easier, whatever helps it work better. And we call this second form exponential form. Here are some properties worth knowing. I would honestly just say pause, write it down, anything you feel like here. Make sure that you are familiar with these properties. Okay, first actual example. So we want to convert this to exponential form. This is in the radical form. Exponential form again means that we're writing it with an exponent that is a fraction. Well, my base is x. Okay. Then I have this 3 and this 2. The index is the denominator, and the 2 is the exponent. Actually, I had one year a class that came up with a little acronym to help remember this. Their acronym was NERD. And what they actually did with this was they said that the numerator is the exponent, so the exponent 2 is the numerator, and then that the root is remember this is the root, this is like a cube root, so the root number is the denominator. So again, NERD was just something that they came up with to help realize that the numerator had the exponent and then the root went in the denominator. So maybe that will help you remember them. Here we're going to convert this one to radical form, and so here I'm just going to go backwards, so like the exact opposite thing. So the 2 is my exponent, so I'm going to have z squared. Always do my z's with a little slash down the middle there. And then I need to put the radical symbol around it. Then the 5 is the root. So this is the 5th root of z squared. That's how you would say that. And then last example, simplify the expression. So here we need to know some of those properties. We need to know that this 1/2 exponent applies to both of, it just applies to the thing on the inside here. I almost thought there were two things, so let me say that again differently here. The 1/2 multiplies the 2/3. So it's just an exponent law that you multiply these exponents together. So whenever I multiply 2/3 times 1/2, notice I'm not dealing with the 125 yet. I'm just simplifying the exponent first. Well, 2 times 1 is 2, 3 times 2 is 6, and 2/6 simplifies to 1/3. So this is 125 raised to the 1/3 power. Okay, well, 1/3 power, I can rewrite that if I want. Like if I don't understand what that means and how to solve it, I could rewrite it as a root, where my denominator 3, that's my root, so it's the 3rd root or cube root, and my 125 on the inside is raised to the 1st power, so I don't need to write that. And as it turns out, the cube root of 125 is just 5. So the answer to that was just a 5. Okay. So again, just go back, look over that. The main thing you're looking at is converting back and forth, and then also pay attention to those exponent laws. Okay?